So we'll see about pointer data type. This, if I declare here int asterisk of p, so this pointer is going to be of type int. Same way, if I declare a pointer of type float by giving an asterisk of pf, then this pf is going to be of type float. Now, how many bytes is allocated for this p and then pf? Actually, what happens is, now if you take a random access memory here, so let's start from a location 1000 as the starting point. So second location is 1001. Now, if I give here int of x, so 2 bytes will be allocated. Here, let's take here, these are the 2 bytes has been allocated for integer x. Same way, if I declare a float variable, that is by giving a float of y, for this y, 4 bytes will be allocated. Let's take somewhere here 4 bytes has been allocated. So these 4 bytes is been allocated for y. Okay. So x integer will occupy 2 bytes, whereas float will occupy 4 bytes. So this, the starting location of x is here 1005 and second location is in 1006. Same way, whereas in case of float, 4 bytes has been allocated. For y, 4 bytes has been allocated. Let's take your starting location as in 1007. So up to 100. This is going to be at 8, 9 and then 8. So this is how the memory allocation is done for variables. But same thing if I declare a pointer, okay, by giving here int asterisk of p1 and float asterisk of p2. So now how many bytes is allocated for this p1 and p2? Now see here, whether it is an integer pointer or float pointer, it is going to hold only one single address, that is a starting address. It's not going to hold, here in this case integer pointer, it is not going to hold both the addresses. Same way if it is a float pointer, it is not going to hold 4 addresses. It will always hold the first location address. That is, inside this P1, we are going to store nothing but 1005. Same way in case of your P2, which is of type float, even in that case also we are going to store here 1007. That is, if this P1 has, if I want to make it to point to this x, in that case P1 will have here 1005. Same way if this P2 has to point to this y, then it will hold here, it's nothing but 1007. Now, in both the cases it is holding one address, a single address, okay, not all the 4 addresses. Each address is actually made up of 2 bytes. Every address is made up of 2 bytes. Hence, the pointer may be of type an integer or it may be a float. It will always occupy here 2 bytes. Inside this location, we are not going to store an data. We are going to store just an address, and that also only starting location address. Hence, all pointer, maybe it is an integer pointer or float pointer or double pointer. Same way, it may be a pointer to pointer. All pointers is going to occupy only 2 bytes. Even the same thing even in case of character. So if I declare here a character variable by giving here character ch, okay, so this ch is going to occupy 1 byte. So character variable will occupy 1 byte. So let's take here the ch is occupying a location at 1000. Same way, if I declare a character pointer, by giving here character asterisk of p3, in that case this p3 is going to occupy here 2 bytes. Why 2 bytes for p3? That's because it has to hold this 1000. So this 1000 is base of 16. 4 nibbles are there. So 4 nibbles, that's going to be nothing but 16 bits. So if I take here 1, it's going to be nothing but 0, 0, 0, 1. So second 0 is going to be 0, 0, 0, 0. Third 0 is 0, 0, 0, 0. And fourth 0 is going to be 0, 0, 0, 0. This is a base of 2, whereas this is a base of 16. So this 1000 is made up of 2 bytes here. It is made up of 2 bytes. Hence, even this P3 also has to hold that 1000, which if it has to make it point to this CH. That means to hold this 1000, we needed 2 bytes. Whereas inside this CH, we're going to store a character data. Inside CH, we're going to store a character that is an alphabet A. But inside P3, we are not going to store character data. We're going to store an address. Okay. Every address is made up of 2 bytes. Hence, even this character pointer is also going to be made up of 2 bytes. All pointers and pointers to pointer is made up of 2 bytes.